Third one is slightly different. Okay, in this video, we are basically going to solve these three problems. But not just like solve, we'll also gain new insights into solving differential equations, right? Like if you have not seen all these three equations, like if you haven't ever solved them, then you are the perfect audience for this video. And yeah, we'll definitely learn a lot of new stuffs and basically get the insights like behind those in this video. Right, and the third one is slightly different and that makes it more interesting. Let's first go with the first one. Y double derivative. Over here, know that y is a function of x, and double derivative basically means like dy by dx, and if it's double, then that's d square y by dx square. Single derivative, double derivative. Okay. So we want to solve this differential equation, right? Okay. So for this one, like we want to find the function y which satisfies this equation. Basically, if we want to find a function y which is like function of x, that when I put that y function into this operator, right, I will get 0 as the answer. So notice that if I take some polynomial functions, so in polynomial function this will be of degree n and one of the degree will be reduced and degree will again be reduced. So like the x to the power n over here will not get cancelled, and I don't think we can get 0 over here with the polynomial functions, right? Because yeah, this will have some more degree, and due to is that will not get cancelled and we cannot get 0. But like what do you think about sine and cosine? Even in sine cosine, let's say if this is sine, this is cosine, this is sine, so this will not get cancelled, right? And we want to cancel everything. So we want to search for something that like doesn't really change, and I think that gives you the idea about exponential function. So basically, like there will be some exponential function in the form some constant times e to the power lambda x. We need to adjust this lambda according to the equation, right? And this will be able to solve the equation because lambda x will be unchanged and c will also be always c, and in every derivative we will just get lambda in front of us, right? So over here, if we take we get lambda over here, lambda square over here, we can take c to the power lambda x as common and then solve those like quadratic equation of lambda. I mean what I mean is, so let's assume that there is solution of this form, then double derivative will just be, okay, so first of all we are just assuming that there's a solution of this form and then we will try to find the values of lambda and c. Minus 8 c to the power lambda x is equals to 0. If we differentiate this, this will be c lambda square e to the power lambda x minus 2c e to the power, minus 2c lambda e to the power lambda x minus 8c to the power lambda x is equals to 0. You can take c to the power lambda x common. That will give you lambda square minus 2 lambda minus 8 is equals to 0, right? Now over here in this equation, if you want to make this 0, this will definitely not be 0, right? Either you can make c 0 or you can make this expression 0, right? Now, if you make c 0, we'll definitely get a solution y is equals to 0. This is definitely a solution because it satisfies this equation, right? But this is such like simple solution that we might want to find something like good or something that has some mass. I mean something that looks like a solution, right? This is so trivial. Okay. Now, like if we, that means we also don't want c to be 0. So we want this to be 0. Lambda square minus 2 lambda minus 8 is equals to 0. This will be lambda square minus 4 lambda plus 2 lambda minus 8 is equals to 0. This will be lambda minus 4 plus 2 lambda minus 4 is equals to 0. So lambda minus 4 lambda plus 2 is equals to 0. So lambda is equals to 4 or minus 2. So if lambda is 4 or minus 2, this equation over here, no matter what c be any non-zero number, doesn't matter what the c is, for 4 and minus 2 this is gonna be 0, right? So due to that this entire thing will be 0. So that means no matter what c is, if lambda is 4 or minus 2, this expression will go to 0, right? So yeah, so that means like this entire expression is satisfied by c1 e to the power 4x, first some number c1, and also by c2 e to the power minus 2x, right? So if these two equations are satisfying this equation, I can also say that their sum will satisfy the equation, right? Because while differentiating, we can just treat them as like separate elements, like we can just, because differential is linear, and then we can just go on adding these components of this like function over here while doing this operation of this function over here, and then both of them will add to 0, so eventually gives 0, right? So yeah, a general solution for this differential equation over here, a general solution for this differential equation over here will be for this one will be c1 e to the power 4x plus c2 e to the power negative 2x for any values of c1 and c2. For any values of c1 and c2, this differential equation will be satisfied, right? Okay, c1 and c2 can be determined if there are additional restrictions over here, but there are not. So yeah, this is our solution for now. You get the idea, right, for how we solved it? So yeah, so the solution for this one is the c1 e to the power 4x plus c2 e to the power minus 2x for any values of c1 and c2. This will always be satisfied. C1 and c2, even if they are 0, this will be satisfied, right? Yeah. Now let's try to solve this equation. So already it was 0, so we try to find out something that when differentiated, that was like itself, like that means, so that it would get cancelled, right? And now we don't have 0, we have something different. This time it's slightly different, yeah. Now this time we want this expression, after we apply this to a function y, we want the result to be e to the power minus x, right? So now what you might think is, if you want to get this result, so definitely we need to have y as some expression in the form a to the power minus x, and we can choose a by applying this operation and making sure that that result will just be e to the power minus x, right? So yeah, if you are thinking that's definitely right. That's not wrong. So yeah, let's assume that this is a solution, and then go on finding a, right? Okay, and so it will be, if I take double derivative, single derivative will just be negative a to the power minus x. Double derivative will just a to the power minus x. So double derivative is a to the power minus x minus 2 times this is minus a to the power minus x minus 8 times a to the power minus x. That should be a to the power minus x. So a to the power minus x should be a plus 2a minus 8a, right? Okay, so a to the power x should be minus 5a. So that means minus 5a should be equals to 1. So a should be equals to minus 1 by 5, right? So that means our solution for this equation is y is equals to minus 1 by 5 e to the power minus x. Okay, so get this, right? And also yeah, I think yeah, but do you think that this is the most general solution? Do you think that like only this is the solution, guys? Okay, over here I know that, like, if I just substitute this values in the y over here, in the y in this operator, right over here, we know that if I substitute this one, this entire operator will just give the answer result as 0, right? Yeah, if I just substitute this value for y, I will just get 0 from this expression, right? So yeah, so what if I just added c1 e to the power 4x plus c2 e to the power minus 2x in our solution, so for this expression, our y double dash minus 2y dash plus 8y. Okay, so this entire expression, if I substitute y is equals this one, it will just give it to the power minus x, right? And if I substitute this one, this will just give 0, and then this one will just give 0, right? And I can just add these three. So yeah, so what I'm still getting is e to the power minus x, right? You get that? You get it or not? Because I can differentiate them separately, because yeah, differentiation is a linear operator. Like, I mean, if I put this entire thing in a differential, I can differentiate them separately, right? One by one, and I can differentiate one by one, and just add these two. We know that for them, this entire thing being added goes to 0, and only this one will give it to the power minus x. So yeah, this also works, and this is basically the most general solution. Please don't forget that. So if you have such expression, like the answer would be, and there's a term for these things. This thing over here is called a particular solution. Particular solution, which is basically found from the given expression itself, and this is called the complementary solution. Complementary solution, which is basically found out substituting the e to the power minus x over, I mean putting it of 0 over here in the right hand side. So yeah, these do have names, and this is complementary solution, and there's particular solution. So whenever there's a case we need to find some particular solution, also please don't forget that you can add the complementary solution too, because complementary solution will just go to 0 when you apply this differential equation. So yeah, that won't hamper your solution. That is it. And now let's go to third one. I guess you get the idea, right? Now it seems like in third one also we need a complementary solution, right? It looks like we need a complementary solution. So let's see. But I said it's different, right? So let's see how that's different. Y double dash minus 2y dash minus 8y is equals to e to the power minus 2x. And we already know that for this equation y double dash minus 2y dash minus 8y is equals to 0. The solution was c1 e to the power 4x plus c2 e to the power minus 2x, right? Okay, so we know this, right? Now over here also, you might want to find the particular solution. I have already told you what that is over here, right? This is the particular solution over here. Okay. Now over here also, we will have some particular solution. To find that, you might want to like assume that the particular solution is a to the power minus 2x, right? And yeah, that's what I did at the first as well. So, but there's some trick involved. So let's see what happens if I assume this as particular solution. I will just get, if I take double derivative, this will just be 4a to the power minus 2x, and the first derivative will be negative 2a to the power minus 2x minus 8 times a to the power minus 2x, right? And you want this expression to be equals to this one and solve for a, right? So what this gives, let's see. So this is 4a plus 4a minus 8a, so e to the power minus 2x times 0. So there's no way you can get this, right? And do you know why you couldn't get it? Because we had already found out that this expression basically some constant time e to the power minus 2x. This was actually the solution for this entire expression being 0, right? So definitely, because this is the solution to this entire expression being 0, if you substitute that solution, definitely it will be 0. So there's no surprise in this, the LHS being 0, and you can and like this will not help. This will not be helpful. So yeah, so if this is not helpful, then like which function do you think I can use to get e to the power minus 2x? Because we need to get that right to solve this differential equation. So yeah, even though e to the power minus 2x did not work, even though this one did not work, what you can try to do is, you can try this function, ax e to the power minus 2x, because when you differentiate, eventually you are going to get a to the power minus 2x minus 2ax e to the power minus 2x, right? So here is that what you need. And yeah, you through such expression you might be able to get what you want, right? So yeah, you can try this one. And if this also doesn't work, then we can possibly try this one too, ax squared to the power minus 2x, right? Because this one also, when double derivated, like that x square reduced to just 2. So yeah, there are possible options. Let's try this one. And also you can try the combination, yeah, and things. Wait. Okay, so let's try this. And let's try to find for a. And let's try to see if that will help us to get e to the power minus 2x or not. So if I take the first derivative over here, this will just be a e to the power minus 2x minus 2a x e to the power minus 2x, right? Okay, now second derivative is a to the, sorry, Second derivative is minus 2a to the power minus 2x. This is minus 2a to the power minus 2x. This is plus 4ax to the power minus 2x. So this is basically minus 4a to the power minus 2x plus 4a to the power minus 2x. 4ax to the power minus 2x. Now we want y double dash minus 2y dash minus 8y is equals to e to the power minus 2x, right? So negative 4a to the power minus 2x plus 4a x to the power minus 2x minus 2 a to the power minus 2x minus 2a x to the power minus 2x, and then minus 8 ax to the power minus 2x is equals to e to the power minus 2x. Now let me take e to the power minus 2x common. There's minus 4a and then minus 2a and then just this. Now e to the power minus 2x, x to the power minus 2x, 4a plus 4a minus 8a. See, there's some magic happening. To the power minus 2x. Now we know that this will just go to 0. So yeah, e to the power minus 2x times minus 6a need to be equals to e to the power minus 2x. So for that, minus 6a needs to be equal to 1. That means a needs to be equal to minus 1 by 6. And yeah, so yeah, if you have y is equals to minus 1 by 6 x e to the power minus 2x, so yeah, this operation will just give you e to the power minus 2x, right? So yeah, this is our complementary solution that solves this differential equation. But yeah, but this is not the most general solution. Definitely this is the solution, but this is not the most general solution, because we can also add this complementary solution which will just reduce to 0 when we apply this expression, right? When this operation, right? So yeah, to make the solution more general, you can just add those complementary solutions as well. Plus c1 e to the power 4x plus, I should have written this a bit up, plus c2 e to the power minus 2x, and yeah, this is the solution. So hope you understood these things and hope this is helpful for you. And hope, like, if you were unknown to such differential equation, this helped you gain some new insights. If it was helpful, definitely share to your friends as well, or definitely comment. Yeah, that does encourage me. So that's it for today, and I look forward to seeing you in the upcoming videos too.